Alright, so this video is an extension from the previous one where we want to integrate the second part of improper integration. Alright, so in the first part of improper integration, generally you can see very obviously that in your limit you're having an infinity sign. Alright, and then for the second part here, the improper integral actually involves the infinite discontinuity. So again, when you look at it, you'll ask what is it about. No need to worry about it. Okay. So for this second part of improper integration, if you look at the question itself, you'll find that there's no infinity can be seen in the question. It looks like a very common and normal integration only. Alright, but you need to double check with the question itself. Okay, so I just show you some example first and then we further discuss it. Alright, so if you look at it, for this one, when you look at it, it's just like a very normal type of integration, right? But why we put it under improper integral part? Okay, so the reason is because this one, you see the limit and you realize that when you try to substitute the limit into the original function, okay, so 1, you're having 1 over x power 1 over 5, right? So you're having 1 over 0 power 1 over 5. So what is 1 over 0? It is a math error or it is undefined. So this kind of value is undefined. Alright, because of this, therefore we put this integration as an improper integral. Okay, so that's a reason why we do it like this. Okay, and again, when you're having this kind of improper integral, again, you need to write out a very special symbol to continue with your integration later. You still can integrate, just like the way that you write is a bit special, right? Okay, so part B, we discussed it. Right, and then we are looking at part C. Okay, if you look at part C again, if I take this limit and I put it into the x, you will see that I will get 1 over 0 as well. So therefore, it is an undefined case. Alright, it is undefined case. Therefore, we also put it under improper integration. Okay, because suppose it should be undefined, but how can I actually try to integrate it, right or not? So therefore, it belongs to an improper integral part. Okay, then part B is a bit complicated. If you look at 0 or you look at 3, right? No matter you put in a 0 or no matter you put in a 3, you will realize that, this function actually is defined. But you are having 0 and you are having 3 here. When you do this integration, in between you're having a value 1, right? Okay, so again, if this value 1, when you substitute it into the function, 1 divided by 1, you get a 0. So and now you're having 1 over 0 also. Again, it is an undefined case. So this is the reason why these 3 parts of integration, we put it under improper integral. Okay? Alright, so you need to double check for this kind of question. You need to be careful a bit. Alright, so when you're having all these improper integral again, when you write out the solution to solve this question, it is a bit special. There's a proper way for you to write it out. Okay, so you go to our notes here. Okay, so if you look at our notes, you'll see that, okay, originally I'm having this integration. It looks like very normal. Okay, but for this one, it is the case where you substitute the value a originally into the function, you'll get an undefined case, undefined value. Alright, therefore, they will substitute the a by using the c first, the letter c. Okay, then they put it as limit of c approach to a plus. Okay, then for the next one is, again, the integration looks very similar. Okay, it's very common, like a very common example that we do before. But when you put in the vp into the function, you'll get 1 over 0 also. Alright, to write it out in the proper way, you substitute the b by using a c first. I replace the b by using a letter c, and then for the c, they write as b power negative. This one is a power positive. Okay, so maybe now you ask, what is this? Why do I have a positive and also b negative? Alright, okay, so just a very simple clarification. Okay, so let's say you're having number 2. Okay, so number 2, left hand side got value, right hand side got value. Like right hand side is 3, 4, 5, and so on. Left hand side one is 1, 0, and so on. Okay, so if let's say your value, your integration is coming from here, okay, from the left hand side, this part we write as 2 negative. But if let's say the value is mainly focused on the right hand side of 2, then it is 2 positive. Okay, all right. So we take an example here. So for this integration, your integration is from A until B. All right, so your integration actually involves this value. All right, so I don't bother the left hand side of the A. I only focus on the right hand side of the A until B. Okay, so that means when you are doing the integration, you only want to focus on the value which is A positive one. That means start from the right hand side of the value A. Okay, right, so that's why they write as A positive. Okay, then the same thing happened here. For this one, original question, I want to integrate from A until B also. But you know that when you substitute the B, you'll get the mass error, okay, or undefined case. All right, so again, integration, I only want from A until B. But for the B, when I substitute the value right into the function, it is an undefined case. Therefore, I cannot write out like that. So I will replace it as C. And then C, I want to focus the value of B from the left-hand side of B. So it is B power negative. So that's the meaning. Okay or not? All right. So later I will teach you also how to write it out in proper way in the solution down there. Okay. Right. So if let's say you roughly know the idea, then we can start slowly to discuss example 20. Okay. So if you look at example 20, as what I said, it looks like a very common integration question only like what you learned before. Okay. But you need to double check before you do any integration first. If let's say the 0, when you substitute into the function, you get 1 over 0, which is an undefined value. Okay, so in this case, it belongs to improper integration. Therefore, when you want to write out the integration symbol, it will become limit. So for this one, again, I use A. Okay, so the value start from the right-hand side of 0, so it is 0 plus. Okay, because you want to integrate from 0 until 1, right? So your value start from here. So it's 0 plus. Okay, you are not going to consider this part of the value 0. Right now, it is from 0 until 1. Therefore, it is from 0 positive, 0 plus. Okay, then for the step here, I will substitute it as A and also 1. 1 over x power 1 over 5. If I rewrite again, I will have 1 negative 1 over 5. Okay, so this is a special symbol that you need to write out for this improper integration. Then after that, again, you can start with your integration rules already. How you integrate x power negative 1 over 5. So plus 1 becomes 4 over 5. And then this whole thing is 4 over 5 divided by the new power. Alright, so I'm having 1 and 8. Okay, so I don't like the constant to be in the fraction. It looks like very complicated, so I will just take it out. Okay, so I just left x power 4 over 5 and then 1 and 8. Okay, so now substitute the 1 into the equation, you have a 1. Substitute the a power a into the equation, you're having a power 4 over 5. Okay or not? Alright, so when you substitute the a and now you need to take the value a should be 0 positive. So what is the meaning of 0 positive? So 0 positive means that at the right hand side of 0, a value that's very, very, very close to 0 from the right hand side. So what is the value? It can be 0.000000001. Let's say that because it is a very small value that is very close to 0 from the right. Okay, so if you want, you can just assume that it is 0.0000001. Okay, so can you imagine when 0.00001 power 4 over 5, why is it? It is also a very small value, right? So which is almost equals to 0. Therefore, when you simplify the answer, it will become 5 over 4. Right? Can understand or not? So I hope that you can understand this. Okay? Alright. Okay, so the integration process is still very similar like what we learned before, just that the way of writing it up is a bit different. So, and some more for this kind of improper integration, you need to actually try to identify yourself. Okay, all right. Then now, because part B is a very special case, so I would like to discuss it later. Maybe I focus on part C first. Okay, so for part C, how can I get the improper integration here? So I think just now I told you already, right? When you substitute the value 0 into your x, you will get a 1 divided by 0, which is an undefined value. All right, therefore, you should write out in a special way because it is improper integration. All right, so again, oh, sorry, it is not 0. When you substitute 1, sorry for that, blur case. All right, so when it is equals to 1, substitute into the equation, you get 1 over 0. All right, so now, the proper way that you should write out your value is something like this. Okay, so 0 until c. And then when you want to integrate from 0 until 1, right, we consider this, the value from left-hand side of the 1. So it should be 1 power negative. So that means from the left-hand side of 1. Okay, so again, for this integration, I'll write as 1 over x power negative half. All right, so when I write out the symbol correctly already, then I can start with the integration. Okay, so to integrate this one, power plus 1 become half. You divided it by the new power. Differentiate the thing inside this bracket, you have negative 1. Then you put in c and 0. Okay, all right. So now again, I would like to take out the constant first. Okay, so my equation become 1 minus x power half. Then you want to put in c and 0. Okay, so negative 2, you are having a limit c to limit 1 negative. Okay, so you are having 1 minus c square root. Okay, then minus 1. 0 you put it in is 1 minus 0 is a 1. And 1 is a 1. Okay. Okay, then now you can imagine. I want to put in the value c is 1 negative. If this is 1, where is 1 negative? 1 negative means from the left hand side. This is 1 negative. Okay, so after that you get a 2 on the right. Okay, so now I want a value very, very, very close to 1, but it is from the left hand side one. So it should be 0.999999. Okay, so when you look at it, 1 minus 0.9999999, it will become a very, very, very small value. When you take square root of a very, very, very small value here, you'll get a 0. Therefore, you're having negative 2, and then you are having 0 minus 1. Then eventually you have a 2 as your limit of your equation. Can see it or not? Alright, so this is how we actually do this kind of question. Alright, it is a bit special in the sense of writing out the solution. Okay, it is very different from what we learned before. But the concept, the integration step is exactly still the same. Okay? Alright. Then now let's continue to the last example. This is a bit troublesome. Okay, because as what I told you just now, the undefined value is at 1, correct or not? Okay, therefore, you need to actually split this integration into 2 parts. The first part is from 0 until 1, from the left-hand side of 1, and after that, the second part is from 1 until 3. Okay, because if you put in the 1, it is undefined, so you cannot write it out like that. Okay, you have to split it out. Okay, so how to split it up? My step will look like this. Okay, so again, first you can use the limit. Okay, b. So first I focus on this part first, from 0 until 1 negative. Alright, so b is 1 negative. Okay, if I integrate from 0 until b, then x minus 1 power 2 over 3 dx. So this is the first part. Okay, then plus. Now, again, I'm having limit b. The second part is from here until here, from 1 plus until 3. So now I put in the value for 1 plus. So your b now is at here, b until 3, x minus 1, 2 over 3 dx. Can see that or not? So this is a more troublesome case because you need to split it, become two different integration. Alright, so I think I make a careless mistake here, right? Here should have a negative value, negative power. Okay, alright, can Okay, so this makes our life a bit harder. Alright, because from 1 into split it becomes 2. Okay, so if you continue with the integration, the limit, the concept is again still almost the same. Alright, so if I integrate this, what do I get? I will have x power 1 minus 1. This power plus 1 become 1 over 3 divided by the new power. Oh, sorry, I forget to put the limit in front. Oh, yeah. Okay, wait. Alright, so I'm having limit b to 1 infinity. Then I'm having x minus 1 power 1 over 3 divided by 1 over 3. Then from b to 0. Then the same thing happened here. Limit b from 1 plus. And then again, I think the integration is still the same, right? Okay, so b and 0. Sorry, it is not b and 0. It should be 3 and b. Okay, all right. So now again, for this part, again, I don't like the term to be like this as a fraction. So I write out. I'm having 3, then limit b 1 minus. Okay. Now I want to put in the value of b. So I'm having b minus 1 power 1 over 3. Okay, minus, I substitute 0 into this. I will have negative 1. Okay, so the 1 over 3, I already take it out as a constant. Yeah, then plus. For the second part, I'm having, again, 3, I take it out. And I'm having limit b 1 plus. Okay, substitute the 3 into the equation. 3 minus 1 is a 2. So you're having a cube root of 2. Okay, then minus. Now you put in the value, the b inside. So you're having b power 1 minus 1 power over 3. Okay, all right. Then now let us imagine I want to have the value of b from negative side of 1. Okay, so again, I don't know whether you can imagine or not. Let's say this is your 1. 1 negative is here, 1 positive is here. So this is 0. Okay, so what is the value that you can put in for 1 negative? You can put in 0.9999999. Okay, so okay, imagine if you put in 0.999999 here minus 1, you will get a very small value, which is negative. Okay, but no matter how, this a very small value, a very small value that is equal to 0. All right. Therefore, what do we have for this part is, okay, so I write here, the 3 is a constant, you just copy, and then you're having 0 plus 1. Okay, then plus 3 again. Okay, then now you need to put in the value of 1 from the right hand side. So that means from the right hand side, the value that you can choose is 1.00000001 from the right hand side. Okay, so 1.000001, if you put it into this part, okay, 1.000001 minus 1, you get a very small number, which is very close to 0. Therefore, again, we are having cube root of 2, then minus 0. Alright, okay. Then, again, you can try to simplify your final answer here. So what do I have? Okay, so 3 multiplied with 1 you get a 3. Then this one you are having 3 multiplied with cube root of 2. So you can write it as a final answer like this, or you can write as 3 and then 1 plus cube root of 2 also can. Okay, hopefully I didn't do careless mistake here. If I did, then please let me know. Maybe you try to Facebook inbox me or what, then I can correct it. Okay, but no matter how, you will see that for all this improper integration, generally the steps that you write up in your solution is a bit troublesome or long, a bit special I can say. Alright, so just make sure you know how to write out correctly, especially for this second case here. Somewhere you need to involve all those 1 power negative, 1 power positive like that. Okay, so please make sure you understand the concept. So that's why we say we are not going to cover the very deep part on the concept, okay, but we just want to learn how we actually write out the solution correctly, just using the basic concept of integration. Okay, all right, so again, as what I said, this is a new syllabus in year 2020. Therefore, when you are trying out the past year papers, right, you actually will not see any kind of this kind of question. Okay, so but no matter how, please make sure that you know how to write out the solutions properly in a proper like this. Okay, all right. Okay, so and I want to end this video already. So ended of this video also means that we already covered everything in our AS syllabus for pure maths. All right, so we're having 8 chapters in total. So for your final exam, definitely we will include all the topics from chapter 1 until 8. Alright, so after you complete the solutions for example in your notes, then I think it's time for you to try all the questions behind the topics and also the past year paper by year. You can actually download the past year paper by year from internet. I think it's the most convenient way instead of you go and copy it from some other friends or what. Alright, okay, so that's all for today.